So let's look at one more example where we have the equation of a circle in its expanded form and we want to graph it. Now, the general strategy is to transform this to the standard equation of a circle. And from that, we can figure out the center of the circle and the radius of the circle. And the process for transforming it is completing the square. We'll need to complete the square for the x terms and the y terms. And remember that completing the square is essentially based off of the formula for a perfect square, where if we have x plus some constant squared, that when you multiply this out, you get x squared plus 2ax plus a squared. And if you forgot where this formula comes from, you can just rewrite this twice and then multiply using distribution. So let's rewrite this so that we can actually complete that square. And we'll do that by grouping the x terms together. So x squared plus 2x, and we'll leave a space since we essentially need to figure out what number we need to add so that we can transform our quadratic expression into a perfect square. Now for the y values, we have plus y squared plus 4y. We'll leave a space again, and we'll move the constant term to the other side. So in this case, we will add 44 to each side. And when completing the square, we essentially have this right here, whether it's for x or for y. And we need to figure out what number we need to add so that we can transform this to a perfect square. And to do that, we just need to look at the coefficient on the first power term, whether it's x or y. So in this case, it's a 2. And the coefficient on x is twice a. So if we divide this coefficient by 2, we will get a, and then we can square that number and add that to each side of the equation. So with x, we will take this number, divide it in half, and that will be 1, and then we will square that. And 1 squared is 1. So if we add 1 to each side of this equation, then we can take this quadratic expression and rewrite it down here as x plus a squared, where again, a is just half this coefficient on x. So in this case would be positive 1. And you can check this by just re-expanding this. X plus 1 times x plus 1, if you multiply that out using distribution, you will get back this quadratic expression. And that is essentially an effective way to check that you're doing this correctly, that you're completing the square correctly. Now with the y values, we will repeat the process. We look at the coefficient on y, we cut it in half, and then square that. So 4 cut in half is 2, and 2 squared is 4. So if we add 4 to each side of the equation, then this quadratic expression with y can now be transformed into a perfect square, just like we did with x. So this will become y plus a squared, and a in this case is, again, half the coefficient on the first power term, so half of 4, it is positive 2. And if you want to check this, just multiply y plus 2 times y plus 2. If you multiply that out, you will get back this quadratic expression. Now, for the right-hand side, we just need to add these numbers together. And 44 plus 1, that's 45, plus 4 more brings us to 49. Now, if we compare this to the general, or I should say the standard equation of a circle, x minus h squared plus y minus k squared is equal to the radius squared, where the center is at h comma k, and the radius of the circle is r. Then with this, we can figure out the center and the radius. So for our equation of the circle, the center has an x value that makes this expression equal to 0. And in this case, it would be minus 1. Now, you could also look at it as subtracting h and rewriting this as subtracting -1. That's another way to look at it, where now you can see h is -1. But in my opinion, it's easier to see it if you just ask yourself which, in this case, y value makes this expression equal to 0, and that would be -2. But either way you want to look at it, since again, this is really just subtracting -2, since that's the same thing as adding 2. So we have -1, -2 for the center, and notice that it's equal to 49, and the standard equation is equal to the radius squared. So r squared is 49, and if we take a square root of each side, the radius is 7. So let's start graphing this, and we will use a scale of 2. So 2, 4, 6, 8, and so on, and same for the y values. And plotting this at -1, -2, here is -1, here's -2, and we have a radius of 7. So if we go up directly or vertically 7 units, that will bring us to a y value of 5. The x value stays at -1. And if we go down 7 units, that will bring us to -9, which will be, let's see, this is -4, 6, 8. So here is -9. And if we want, we could really graph it from here. But let's also find the most left and right points on the circle by adding 7 horizontally. And if we're at -1, then adding 7 brings us to 6. The y value stays the same since we're going horizontal. And going from -1 and subtracting 7, so this is -2, 4, 6, 8, would bring us to -8 right there. And let's draw a quick sketch of this circle. And keep in mind, this is just a very rough sketch since we're doing this by hand. If you want a perfect or very close to perfect picture, you can use software to draw this circle. But in conclusion, this is the graph of a circle where the center point is -1, -2, and its radius is 7 units. And we found this from taking the expanded equation and transforming it to the standard equation of a circle.